Maybe is it cool if I go first?
Yeah, go ahead.
All right. Demo day. Lots of cool new things to show. There's a little bit of background noise. I don't know who that is. But yeah, demo day today. Lots of cool things to show. I think what I wanted to lead with was our new API, which is backed by ClickHouse database. So it should be significantly faster, hopefully more stable. I'll basically walk through like what it looks like now, and then how to use it is probably the most important thing, and then I'll deep dive into like how it all works in the background. So I updated the API docs. Fun fact, I don't know if you know this, but you can add GIFs in Dr. Source docs, and it's
No,
actually
nice.
kind of nice. So we have a new public GraphQL Explorer, and it's like embedded within our domain /GraphQL. That's pretty nice. And this, introspects on our ClickHouse schema, so that's really nice. The schema is camel case now. Ruben and I were just complaining about that yesterday.
Yeah.
But if you can get over that, you can, add stuff here. You can add all fields. This is a really nice shortcut that Historia didn't have. One of the things that is kind of weird that you got to get used to is, for one reason or another, you do have to inline variables. So maybe I have like something like this. Traditionally, this should be able to run. But for whatever reason, I get this error message and I haven't been able to figure it out yet. But it's an easy thing to overcome if you just inline it. This is how it
What?
typically shows up in,
Okay, interesting.
but then it'll run. Actually, what did I do?
Huh.
I have a bug in my query. Oh. Okay, sorry. Let me start over. This is gonna be a really cool demo. I clicked the wrong thing, apparently. I forgot to add the equals. So I want to get all code metrics where the project name is equal to this one. Now I can say open source dash observer. I'm going to inline my variables for, again, we're going to have to figure out if this is going to be an issue on the GraphQL API. Okay, notice that this is spinning. This is like expected behavior. Let me explain why this is expected behavior. We are scrappy and we're trying to save on costs, basically. So our ClickHouse Cloud is both really scalable and really cool, but like idles. And so the way that it's configured right now is that we have 3 replicas. So when it's up, it's really fast. It can serve a lot of queries. It can scale up and down, and it will auto scale to a bigger instance. Right now it's idle. Right now we can configure it to whatever we want, but the way that it is configured is it automatically scales up from like a tiny CPU, like 2 CPUs, to like 30 CPUs across 3 nodes automatically, depending on how much load it sees. That part is really cool. And it's currently configured to idle to save on costs. So if it sees that nobody's actually using it, it will sleep. After 15 minutes is kind of what it's currently set to. We can change this however we want, but that this is a function of to be paying for ClickHouse at any given time. It takes about 15-ish seconds for it to wake up. And it can be triggered. The wake up can be triggered from FQL operation. It just takes some time. Clearly a non-zero noticeable amount of time. But that's something to keep in mind. Carl, if you have thoughts on like what we want to set these timeouts to be, or like if Gitcoin's actively using this, maybe we can like spin it up, spin it down. Like we can reconfigure this.
Sounds good. Maybe just having a banner or something that mentions that on the console on our side.
Yeah, this one is taking longer than it usually does, so I don't know. For me, historically, this has been relatively fast, like fast enough for the GraphQL thing to not time out. In this case, it's actually taking a little longer. So let me show some other stuff while we're waiting for it to wake up. So this is all backed by ClickHouse. Let me show the new Hasura console thing. So this is more of an FYI for folks that are actually developing. But Hasura 3 is hidden behind this new URL. And I have to log in, obviously.
Wait, isn't it console? No, console's the old one. Okay. It's
No, I
cloud
think
now.
console is I thought console was the new one.
I thought console was the new one too. Okay, so I'm confused looking at yeah. Oh, Hasura.
Oh, Hasura. Classic Hasura. Here we go.
Even stranger. Yeah, okay. So all auth is through cloud dot. I see.
Yeah, so the old one is cloud dot. You guys can still see my screen, right?
Yes.
The old one is cloud.hasura. The new one is console.hasura. This is our new Hasura instance. It is all, infrastructure as code, right? So the new configs are all in here. If you go to Hasura 3, it's not continuously deployed, so we have to manually deploy it right now. But there's a new CLI that you have to install that's totally separate, and then there's a bunch of new environment variables that you can set. And then there's different ways. I try to just hide it behind PMPM scripts, but there's a new way to basically pull and introspect on ClickHouse. I also use like a TypeScript script to automatically update the metadata files to have the access control that we want. And then I'm trying to hide as much as possible behind PMPM scripts. So if any of this doesn't work, let me know. But it's all here. So our Apollo GraphQL thingy is basically just a proxy for this thing. And what's really nice about the new thing that they have is like we get symmetrics basically. So we can actually get a sense of like errors. We can get a sense of latency. We can get a sense of tracing. The tracing feature is super cool. Where is it? It's up here. So like for each request, you can actually see exactly the breakdown of why things are slow. Whether it's the router, whether it's like the ClickHouse, yada, yada, yada. So that part is super cool. And then we don't pay for this yet, but if we end up paying for this, they'll actually give us model analytics of like, which models are people touching, which fields are people getting, stuff like that.
That's
so
awesome.
The new features are actually pretty cool. No complaints. Okay, so this is running now. So all of it is backed by ClickHouse, significantly faster, and you'll notice this. Like making queries against artifacts by project is totally not an unreasonable thing to do now, where it was with Postgres. So I think our database is like 30-ish gigabytes because we're only copying marts right now. We can definitely play with the idea of copying over more because I know ClickHouse can handle a lot more than this, but this is just all of our marts right now. And yeah, I don't know. You guys should play with this. It's like significantly faster. So let's try this again. Just as I was promising that it'd be significantly faster.
Just the same.
This took about 7 seconds. I think the other thing that's a little bit weird is that like not all the replicas pop up at the same time.
So okay, I see.
But I don't want to.
So you might be hitting, like you might be routed to something that is still waking up, which is why, perhaps.
Possibly. But I don't want to make excuses for ClickHouse. Like we should just stress test this and you let me know if how things are running. This is the kind of query that would have been impossible to run in Postgres. Like it would literally time out. And now it's taking about 3 seconds to fetch all of our artifacts. Like that's a win in my book.
Yeah,
automatically fast.
That's great. Yeah.
we do have the ability to set indices, and we are setting indices. So this is just like a friendly reminder that if we want a performance tune, here are the two ways that we can do it. So in DBT, if you go to models, if you go to marts, let's say, for example, artifacts by project, these indices are built now. So if you specify, I want to sync it to the database, and I want to be able to fetch things by ID or fetch things by project name, these things will be built. It is built in a really naive fashion. So this is another area where we can performance tune a little bit. So for example, it's just hard coded right now. When I create a table, where is it? Create table. I'm just creating I'm creating the indices the moment I create the table, and I'm just using the default Bloom filter one right now. That might not actually be the most performant one, but it is just what we're currently hard coding. So there's a couple ways that we can performance tune this still, but you will find that like it is better. things are better. So that's that. And then the last thing I was going to show was just like how to materialize this in Dagster.
Ray, will we need to reach out to developers that are using the API, which previously had things in?
It's a breaking change for sure. Yeah, this is like unfortunately.
Yeah. So the main reason why it's a breaking change is because Hasura 3 has decided to camel case everything.
Like, I find it strange that they didn't have just like a simple option to leave it looking the same as the old one, because don't they want people to upgrade, so without breaking changes? But yeah,
Hasura 3 is, I think they've just given up. Like when you play with Hasura 3, you'll realize just how different it is.
Yeah.
I think they've just given up.
So are we going to maintain Hasura 2 at all, or we'll just turn it off?
Sorry.
Oh yeah, we're gonna get rid of Hasura 2. Yeah, because it doesn't work with our ClickHouse. So
got it. Okay.
Yeah, Hasura 2 doesn't work with ClickHouse, so we're just gonna throw all that away, basically. At some point, I think we should stress test this though. Like we need to hook this up to our front end to see how well it performs there.
Okay.
We need to be interacting with this graph. Like if you are making very simple queries, I would strongly suggest that you try the GraphQL thing instead, just to help stress test it and see like what are the performance that you're seeing. And then when we get comfortable with it, we can ask people to migrate. We haven't shut down Hasura 2 yet, so it's just like stale and stuck.
All right. Yeah, I guess when you say stale, meaning the data's not syncing or that the schema's not updating?
Yeah, data's not syncing.
Okay.
But it's stable. Like it's it hasn't gone down yet. It's significantly more stable than what we have right now in Hasura 3. So the performance is what it is, but it's up, right? This I think we need to play around with a little bit more to see like how stable it is.
Okay.
Any other questions about the API? But I would appreciate it if you guys are doing really simple queries for projects or artifacts and things like that. Just use this and share your experience. And see where. I mean, if you really
want
to
use our client instead of Hasura v3.
I don't know. I mean, that I don't really care about. Like, that's up to you. But this is public, and there's no reason not to use it.
Cool.
The Hasura stuff, I pretty much like, will only use for insights at this point. But up to you. Okay, so materialization. That's the last thing I was going to cover. They are all grouped by /ClickHouse, and you'll see a model for every mart that's auto-generated. You'll see that we are materializing it regularly. This was just synced yesterday, so that's cool. I'm not going to I'm not going to bother running it now, but I'm just going to share what it looks like and what it looks like when things go poorly. So you'll see all the logs in here. I'm trying to log better. And all the steps. So basically, here's where we copy it out of BigQuery. Here's where we're starting to create tables. Here's where we're starting to import the data. Here's where we're starting to move the stuff, and here's where we're like cleaning up the old GCS data. So it's all in here. If you need to debug, you can look at these buckets where we're
nice. Yeah. Nice
so
log.
Yeah, nice logs. I'm all about the nice logs. Nice metadata results as well. So
yes, no, that's really the key. Yeah.
if we get stuck, like this is the temporary GCS bucket that we're using to copy data over. So you can always look there and see if things are missing. And then this is the temporary table that we're importing into ClickHouse first before we move it to the right place. So hopefully very debuggable. But it's it's all here. So so there's a couple gotchas. One is that there are no rate limits yet in Hasura 3, which I guess is a good thing. They haven't implemented it yet.
I see.
And
so we've now published to the world there are no rate limits. Yeah, to our API. Yeah.
There are no rate limits. Not only have they not implemented yet, like because they haven't implemented yet, it's not part of their pricing. So I guess that's good.
Oh, okay. Yeah, that's fine.
So use it as much as you want. And what else is the gotcha?
That is not a call to action. Please use it.
Yeah. Basically, what that means is like there isn't actually a strong reason to create an API key.
Oh, you mean yeah.
I mean, I would prefer people still make API keys if in the future we end up changing this, because that will be a breaking change. But like, yeah, in theory, we're just like.
Yeah, I mean, I think we should assume that the API key should be something you create, because we will likely have, rate limits configured once that is available to us, right? So
exactly. So that's why I'm leaving this, this here. The other thing that is kind of cool, as just like a, I get excited about this. I don't know if you get excited about this. Maybe Ruben gets excited about this. Is if you look at our router. Oh, by the way, I also version our API now, so it's behind this V1.
Cool.
So there's this GraphQL subgraph, which is just a hello world. It's literally just a hello world. But this is where we can implement custom API functionality. So in the future, I think if we end up doing weird things, especially mutations, this is where we would do it.
Cool.
The other thing that is really cool is our Apollo router. You have direct access to the request. So in the future, if we wanted to implement our own rate limits, or in the future, if we wanted to implement our own metrics and analytics, or whatever, we have raw access to requests that are coming in, and we can do stuff with it. So I don't know. I'm excited about that.
Cool. So, I mean, I guess we could technically even set up a rate limit on our own if we needed to, for whatever, since we are the front end proxy here, right? So
that's basically what I'm saying. I'm not saying that we should, but like.
No. I'm not saying that we should either at the moment. Like, yeah. Well, let's wait until it hurts, I guess. Yeah.
So yeah, that is the new Apollo-based GraphQL API.
Sweet.
I feel like this is going to be significantly more performant and stable once we test it a little bit more, and so I'm excited to get more people onto it, because like I expect this to fail a lot less, and I expect this to be much more reliable.
Cool. Go for it.
It's been a while since we had one of those. Awesome.
You want to go next, Ruben?
Yeah, sure. Yeah, so a bunch of things to show. Let me pull this up. So Golan. All right. Yeah. So one of the first big things that we got to land, or I got to land for this sprint, was around setting up the API crawling on our Dagster. So we use a tool DLT actually in a couple different places, but one for our SQL and then here for the APIs. But in general, DLT is just a really nice ELT toolbox or ETL toolbox, excuse me, that has various tools to make writing ETL processes in Python a little bit easier, and it integrates directly with Dagster. Now, what we've done is we've gone even further, and we've actually, so if you read through this docs, we actually even make it a little bit simpler by having some of our own decorators that allow just specifying just a resource as opposed to a full DLT pipeline. Most of that is because there's a lot of boilerplate to setting up DLT, like where things go, destinations, and whatnot. And really, when I created this, I assumed that actually most people would want to just send it directly to our data warehouse. So if you use the DLT factory as we go through in these docs, it'll actually do all of that for you automatically. Have that configured in a way that we can change things and you don't have to worry. All you have to worry about is actually just writing the code that you need to. So yeah, just like a quick overview here, basically. This one uses an example that's originally from the DLT docs. And this crawls the Pokemon API for the various Pokemon. And so all you have to do, as you can see here, is specify a resource. And then actually connect that resource into this DLT factory. And then once you do that, this will automatically get discovered by the assets as long as it's or the asset loader, as long as it's in the /assets folder of the OSO Dagster library. So the doc. I don't want to reiterate everything the docs has here, but there is we've done a lot of work to try and make this simple. Maybe one of the things that I would like to go over actually is just setting up secrets, because this is one of those things that I'll put a little bit of thought into, and we know that if you are trying to contribute data into our system, you're going to want to get secrets into you're probably going to want secrets, and we want to store those in a very in the most secure way possible. So we've actually created a system such that it's easy to specify these things both for testing locally and for our infrastructure. So the docs go over this a bit here, but this secret ref actually allows you to specify a secret that you want to pull from some kind of secret resolver, which for our infrastructure uses GCP's secret management. But then you can also configure locally when you're running Dagster to use like an environment variable. So that way, when you're testing this, you should be able to easily, run your DLT resources, to see to actually test for like connections to your API, all your logic here for pulling this down. So but yeah, this, we're hoping that this helps people really contribute new data sources for us, or to us, in a lot simpler fashion, and really tried to also make these docs a little bit cleaner. I took some inspiration from DLT. Actually, they did these, comments with numbers and tried to number these along here, which I thought was very clean. So.
This is awesome. I feel like this is a game changer. Like Carl, there's just like so many API sources we could be crawling from, like including things like DeFi Llama and whatever. Like
Exactly.
Maybe we think about potentially a challenge where we Like this trivializes it, right? Like just look at this code. It's like so
Yeah,
easy.
yeah,
Yeah, yeah. I tried to make it so that there's almost no real boilerplate. You just use our decorators. So
And
yeah.
this is an asset that can be scheduled in Dagster to run periodically. So it literally less than 100 lines of code to crawl, say, I don't know, like to crawl DeFi Llama and put TVL into a separate table regularly on the daily. Like, that I don't know. That's like simple enough that we could potentially even make challenges around this or bounties around this.
yeah. I feel like we should just do a Friday hackathon or something where we take 2 hours and each do 1 or 2 and then document it. And
Well,
get other people to do
this
more.
is the documentation, right?
No, but like say here's one we created and we dropped it in the data warehouse, etc. So just actually do them ourselves.
Yeah, totally. We should schedule some time for that. But in addition to that, like we should, yeah, in the world of as you're starting to think through this collective network data marketplace, I could totally see a world where connectors like this could be one category of things that we're getting help for, right?
But we should definitely do DeFi Llama. We should do Ethereum attestation surface, etc.
All of them. Yeah, Open Collective has been high on my bucket list for a long time. Like,
okay, cool. Yep.
yeah, anything that exposes an API, this like trivializes getting it into our data warehouse.
Nice.
Yeah, super cool. Mind showing the Goldsky data models, by the way? And I'm curious, like,
Yes.
have you shared this with the
No.
Goldsky team?
So I do need to do this, but yes. So the next one, yeah. So the next big thing, and yeah, this was actually quite a big one. So if you so we maintain the Superchain data sets, and actually are hoping to also get things like Arbitrum and stuff in here from Goldsky. But that data, while awesome, sometimes is like we have noticed certain things with our connection, which is not a normal connection. We use GCS. They usually expect S3 or some other form of integration. So I think hopefully we're also helping them debug some of their issues here. But one of the things that we've discovered that some of the data just ends up like not making it to our GCS bucket. So what I've done is I've made it such that part of the materialization for the factories for the Goldsky actually creates a missing block numbers table for every one of these. So you can see here base has a missing blocks numbers table. Some of them might be empty. If we're lucky, they're empty. In the best case scenario, they're empty. And then in the worst case scenario, they're not. So we'll take a look at some of those. But just real quick, you can also trigger a full refresh of this table by going into here. So it should be missing. No, missing. Oh, good. Thought it was, but you don't use from you trigger a refresh and configure do this, and I'm not actually do this just to see where it is, but so needed to do a refresh, double all of base blocks history or base's history for the blocks. We can do that here, and we can do that per these models. So let's take a look at what those models actually look like. They're very simple. Oh geez.
Really dumb
question.
Like we just made a DBT model to join all of them because I imagine there's just like one table that we want to tell them like for what.
Yeah. So no, I don't think that's dumb at all. I think actually that I was thinking through that as well. I think that is a great idea. yeah, just to use like a DBT model to join all the missing. Yeah, I hadn't actually thought about joining them all together, and that makes way more sense. So yeah,
But DBT
that should be simple enough.
do that.
Wait, sorry, say that again.
A DBT model will be the right place to do that.
I think so. Yeah. I think yeah. I think that would be probably the best place to do that transform. Yeah, right here. In order to create this, we do some SQL Mesh, or not. We use some things from SQL Mesh, but nothing really crazy. We're not actually using SQL Mesh to do these generated things right now. But we are using bits of it as a library. But yeah, if we look at this table, superchain. So everything's in the superchain, which is public. So our QA is public, which I think is cool. But so yeah, it's a very simple table. It quite literally only has block numbers listed. So if you look at the preview, yeah, base has 6 missing blocks. And this is a continuously like daily it for every day it goes back the last so yesterday and the day before that to double check for anything that's missing, so that way if for whatever reason between days there's missing blocks, like we'll always catch those things. And then the query is made such that for the time period that it scans, if the query discovers that there's no if one of the things is actually not missing, it will make sure that that's updated here. So in theory, this should be a continuously updated like into the future. Like it will know where we're missing things. We'll only need to do a full refresh when there's something like deep in the past that gets updated, which, yeah, I mean, the queries are, I believe, generally cheap, but that is something that I do want to investigate and make sure that that's actually true for a lot of these things. So,
really random, another random question. They previously said that they saw your spreadsheet of missing block numbers. They try to trigger a backfill. Did we ever confirm that actually went through?
Yeah, so that's actually something that I would like to do here. I need to double check that it actually went through. So I got to compare that spreadsheet with what I have here. I do know that if it didn't go through, because we had a bunch of missing things on Frax transactions, I believe. I believe this is the big one. Yeah, this is the big one. Oh, oops, that's not the big one. Yeah, we had a bunch of missing things, and yeah, it might actually still be missing. So
this is after dealing with their backfill, we still have missing blocks?
Yes, I believe so. Yes. So it's that or yeah, this is after their backfill, according to them, if they actually did the backfill. So I'll need to double check that he actually triggered the backfill for the right places.
So what's nice about doing it this way is that they can just subscribe to this data set.
Exactly.
Right?
Exactly. That was my hope, is to make it public so that, first of all, everybody knows where things are missing for us, but then they also know, right? And, we're all kind of in this,
Do you mind posting a message in the Goldsky channel? Because I don't think they're aware of like our current.
No, they are not yet aware of it. So I do need to fix the Optimism one. I know that Optimism traces are missing things, still. But I was going to do that. But I can get these other ones first because they probably need to start running.
Another related question would be, like, I know we wanted to get OP mainnet blocks and transactions, and then there were a couple of networks where they're trying to migrate to this enriched transaction schema. Did we ever end up doing both of those things?
Yeah, so actually that was, and maybe I need to rerun for Frax again, and that's why. Frax was both missing blocks, and then we also needed new things from the transactions there, I believe. So they did transition us to that other data set. So as far as I'm aware. So yeah, so that was one of those. And then Optimism, now we have enriched transactions for Optimism, which are not being loaded, and that needs to be configured. So I have an issue for that already.
Oh, there is an issue for that. Is that in our
Yeah,
sprint?
there's an issue for that. It's not yet on the sprint board. I quite literally made it this morning. So
Oh, okay, got it.
yeah.
Um, cool.
Yeah, and then
Sorry,
last thing
clarify.
I did. Oh no, that's totally cool.
Just to clarify, the Frax thing,
Mhm.
do we need to run an import job again, or
No, it should just continuously import. So if they start backfilling, this will automatically take care of it.
sorry, I'm just like reacting to a comment that you made earlier about like maybe if we reran a backfill for Frax, it might fill in some of the empty transit.
Oh no
Empty.
no! I meant I had fixed something, and then maybe I should rerun the block number calculation. Frax is a small enough just to make sure that I actually, because Frax is the thing I always test on because it's a small enough network. So yeah.
Got it. Cool. Thanks.
Mm-hmm. Yeah. So, last thing, real quick, just want to go over some of the changes that are in flight for this, which I haven't merged because it won't technically work because the data is not yet merged in. But so here's the nifty artifact page. This is for Open Source Observer. There's optionally a section for on-chain metrics, but that does not appear because this is not an on-chain artifact. So those kind of things are handled, based on conditional logic within what you call Plasmic itself, which is quite cool. I think it's no, this one. Yeah, so we do that. If it's a GitHub source, then it'll show up. And then the other one is if it's any one of these. I probably want to make this a little bit cleaner, but for now I just kind of hard coded this in. So it's that kind of data source. It will show up here. But this section is just now made to be a completely separate. And I guess this is kind of a live review. But yeah, it's made to be its own completely separate component. It would, assuming that these work, it would show these, but I made it so that for things that are not projects, it doesn't show up yet because I know that we're still refactoring that event data provider. So yeah, same thing goes for the on-chain metrics. That's also being transitioned into just a component, so we can just pull these things in here. So
Cool.
yeah,
Sounds like you've really mastered Plasmic.
I mean, yeah, it took a minute to get some of these things. It was funny because I was trying to select all kind of thing, like I was thinking it was almost like more like Photoshop or something, right? Where I could get a big selection box and copy paste a bunch of things over, but it turns out that wasn't true. But turns out turning things into components was actually what I really wanted. So yeah.
Really random question. Like back in the day when we were using Plasmic more often, it was not uncommon for like the studio to like freeze or something weird. Have you noticed anything like that, or is it fine?
No. I don't. Yeah, I haven't had it freeze or anything. Luckily.
Oh,
Yeah, and actually, I've been using branches, which I actually very much like. So, yeah, I'm into it. I did have some weird issues, I think, with I don't know if it was a JavaScript bug, but I was trying to click on something and it would not it just wouldn't register. It was like part of the UI. So I refreshed and it was all fine, but that was the only thing that I saw.
oh, if a refresh fixes things, that's the best we can hope for.
Yeah. So, yeah.
Okay, cool. Yeah, the when you get really scared is when refreshes don't fix things.
Yeah, exactly. Yeah. So, yeah. Yeah,
Cool.
but that's it for me.
Awesome. Thanks, dude. I'll give a clap for that. It was, you still with us, Carl? You wanna?
Oh, you're muted, Carl. If you're.
Oh yeah. Hey, sorry.
All good.
Yeah, let me take over. Sorry, I had something else on my screen. Let me go to the right one. Okay, cool. So I have a couple things to show. The first one is we have been doing a number of things behind the scenes to kind of improve the way that we identify both contracts and then discovered contracts that are downstream from those. As you were talking, Reuven, there's a UX challenge we have to think through about how to go from the 24,000 or so map contracts, which are neatly linked to a OSO project file, and all of the downstream discovered contracts, because we probably don't want to have 127 million possible artifacts that can be displayed. So we'll have to come up with some way of filtering and just making sure that we're surfacing relevant ones. In any case, this is a kind of a snapshot right now of our coverage. So over the past month or so, it's definitely grown in terms of projects, a lot more repos, and then particularly around contracts. Another thing we're kind of checking systematically is the number of contributors across all of the GitHub repos that we're looking at. And so this has bumped up a little bit over the past month or so. So there's about 10,000 plus contributors across all the repos that we care about in OSS directory, which is pretty cool. The other thing that I can share on this dashboard is our own open source observer code metrics. So you can see here that we've been around for roughly 1 year. Our first commit was on the 28th of July, 2023. And we have had a total of 95 contributors over the past year or so, of which 82 have been in the last month. My guess is that 70 or so, those 82, were really in the past 2 months around the Retrofunding 4 activity. So that's really cool to see. Another application of this is a dashboard that we put together for Protocol Labs just yesterday, looking at their own ecosystem and both the kind of project level activity and then some of the repo level insights that they care about. So before actually showing the dashboard, I will first give a quick overview of the data that is powering this. So first off, this is a very simple query here. It just grabs the two collections that they care about. So on the one hand, we have the Protocol Labs network, and then there's also the crypto ecosystems file that is maintained by Electra Capital for Filecoin. This, in my observation, is pretty outdated. There's a lot of projects that either aren't active or are probably only peripheral to Filecoin these days. But in any case, simple query, you can grab all the project IDs, and then coming down here, we can actually see an interactive table of the code metrics for each of those projects. So if we look at, I think this is filtered by, what is this filtered by? Oh no, we can sort it. So let's look at the contributor count in the last 6 months. I love these interactive tables. Oh, it's going to wake up. This might take a second. In any case, this was, last run 20 hours ago, but you can see, here are the 135 or so projects that are in either one or both of these ecosystems. And you can see at the top of the list, you have Filecoin, IPFS, Celestia, even Open Source Observer, a respectable number 7, or 8 in the batting order. And you can check out all the other metrics over here in this table. One thing I like about this is you can also copy it to clipboard, download it very easily. So that's a nice feature for people. The next thing we can do is actually play around with some of the time series metrics that we've started implementing. So hopefully 2 weeks from now, we'll have many more of these available, but this is a first one which looks at the number of developers by project for any given day, taking a rolling 30-day average. And so I'll show an illustration of this in a second, but this is how you kind of grab that data. Very simple. And then finally, we now have repo level metrics that can be grabbed both by project, but then within a GitHub org, and then the repo itself that we care about. So here, again, if we wanted to look at the project with the repo with the most contributors over the past 6 months, let's see what's at the top. Open Source Observer, OSS directory, number 5 on the list. A lot of activity in OSS directory recently. So again, that's just a quick demo of how to get data using Hex and taking advantage of the tables that we've set up recently. Now,
That's
the more
awesome.
interesting part, yeah, it's cool, right? And you can see how simple these queries
Yeah,
are.
this is
I
awesome.
think that's the other thing we want to show is that like this is not going to require doing 100 lines of SQL. It's very, very simple and hopefully readable to even people that are not like SQL experts. Yeah.
You were saying earlier that the Filecoin ecosystem YAML is like a little outdated. I don't know. I'm trying to figure out like, should I be really excited that Open Source Observer is doing so well compared to like all these other more historically like more mature projects, older projects per se, or are we like missing things that are in like the new, PLN? Because like this is an amazing result. Where like actually they're with the heavy hitters, right, in terms of like contributors and all that other stuff.
Yeah, so there's definitely there are a few projects that are kind of new that just got added recently that we haven't indexed yet, but you can kind of get a sense for how popular they are. So if you just take like star count, for instance, a decent proxy for popularity, what we can see here is that there's if we go to kind of down to the bottom of the list, right? These are ones that just haven't been indexed yet, so I don't know these projects. It might not be very big, but you come over here and you just see a lot of projects that haven't been active in really a year or two. So let's put in number 12. Yeah, last commit was okay. These ones are a bit more recent, but in any case, there's a lot that are just not very, very active, or maybe they were added back in 2022 but have since gone dormant.
Yeah, I think like scheduling a meeting with Stefan and walking him through like how to fork this and how to use this, I think this is gonna blow his mind, right?
Yeah, exactly. So I'm learning how to use the dynamic table feature right now, but you can filter out the ones that are null. We'll see what that gives us. Anyway, but yeah, certainly that there are some which have gone quiet. The part that I think is interesting is now actually visualizing some of this data. Oh, so yeah, here again is actually probably the better way to interact with these. These are tables that are already sorted. So yeah, if we wanted to filter,
is this running off ClickHouse data, by the way?
No,
is this,
but we should move that over.
Okay.
Yeah, it's
well,
connecting directly
no, I
to our
mean,
big
again,
query.
we keep saying that, but I don't think there's a plan to have this be supported by ClickHouse, right? Like
Okay,
all of this,
well,
like
yeah.
what like you are not using Marts for these, right?
Nope. Well, some of them
okay.
are. Some of them are, but like this one is Marts. This one is Marts. This one is
Like
not,
how many
but
of
will
these
be a Mart. All
Oh,
these would be
okay.
Marts, actually. All these should be Marts. Yeah.
Okay, cool. Maybe it should be in ClickHouse. I was gonna say, in the meantime, until we until we've moved over the things that we want into Marts, like time series metrics, I would just make sure if you are sharing these things with Stefan, this is it, and we are continuing to use BigQuery. This is exactly the kind of thing that I would really prefer, like them to subscribe to the data set and basically replicate into their own GCP project. You know what I mean? That way we can
Yeah,
get the usage
totally.
analytics. Like if all of these are directly making queries against our GCP project, you lose all that usage data.
Okay.
So
yeah, I have set up service accounts just for Hex, but that's still a good point.
Yeah, I would
Just
strongly push people towards like subscribing and then setting up their own like
nice.
BigQuery query.
Sweet. Okay. Great. Well, here's another version of the same table you saw. This is actually the better way to interact with it. And now here's again, this is me just like playing around for an hour yesterday. You could make much better visualizations. But you can pick a metric. So let's take the contributor count 6 months. This is going to allow us to filter across all the collections. Unique contributors over the past 6 months, of which Open Source Observer brought 82, and you can see the proportions of everyone else in there. These are kind of fun interactives as well, so you can click on that and it animates for you. If we want to, we can actually go in and let you dive into a repo specifically if you cared about that. But those are fun. Time series analysis. So this is also going to be really cool once we have more metrics here. Right now, it's just a few things. But let's take active developers for, let's do the product we know the best, Open Source Observer. So you can see that we had a huge surge around Repto Funding 4 when people were coming in and submitting pull requests. If we just look at the full-time developers, that's, well, we can add both of these actually. So you can see that it's really just the three of us that are committing regularly, but then a lot of people came in to make a single pull request to OSS directory. Again, you could do the same thing for, let's do Filecoin. So you can see the trend. If you want, you can even go all the way back to the beginning. Let's go to 2016. Fun, right?
Cool.
Yeah, this is totally gonna blow minds. I feel like.
Yeah, this is awesome. Yeah.
Yeah, I hope you're ready. Like, you should schedule a meeting with Stefan and the rest of the team there because they're gonna love this. They're gonna absolutely love this. This is cool.
And I can fork this and do it for literally any ecosystem. You just have to change the collection names here, and everything else just happens. The last thing I will show are the repo level metrics. So as you saw, here's the table. Yeah, let's take IPFS as an example. So this is getting the GitHub workspace, and you can see active developer counts over the past 6 months. Let's take forks. Okay, Kubo, IPFS, etc. Let's look at OSS or Open Source Observer. Stars. So there you have it. Oh, and the other cool thing with these plots is you can just click that and you get an image. So very easy to drop into a blog post or something.
Yeah, this is cool.
The last showcase I will give, I actually don't have this in Hex, but last sprint, we onboarded Gitcoin data. So there's a data set called Regen Data, which has all of the historical Gitcoin donations and projects and matching funds that go out. And so we've onboarded that data set into Open Source Observer. A little bit clunky to map between their project IDs and our project IDs. So here's a little utility script to do that. But what we did was kind of do a implementation of OpenRank on top of the Gitcoin data set to see which projects were most highly rated by early Gitcoin contributors. So Gitcoin's been doing rounds for like 3 or 4 years. We kind of look at the OG group that were contributing to Gitcoin well before the airdrop, I think back in 2011 or so, and use that to create a trust seed and then see what projects they support more recently. So here's a notebook that shows you how to do that. This is the query, again, a little bit complicated just because we're trying to map their IDs with our IDs. In any case, we get the data. This covers around 2 million in direct donations from individuals. And then we can build a graph out of that. So again, we're looking at people that donated before 2021. We use that to create our pre-trust seed. And then we run Eigentrust over the graph of donations that they've given. And you can see the projects that are most popular among that cohort. So this is Common Stack. That's kind of a range of different like token bonding curves and things like that. This is a ZK Zuzalu type library. So I guess a lot of people from early Gitcoin days also went to Zuzalu. You have Giveth, you have Umbra, you have Pairwise, which is part of the general magic community, etc., going all the way down. So pretty cool to see. Just a very simple use case. We do, I think these actually, yeah, so if you wanted, you could actually see the data mapping the donor to their Farcaster username. So they actually also have to be someone who's on Farcaster. So that's a slight twist on the data here. But just a cool implementation using OpenRank. And we also have a data challenge right now together with Andrew Hong of Byte Explorers to apply OpenRank on the events table in more ways. So here's the Gitcoin example that I just gave, a few other tutorials, one using a Hex notebook to show developer rank, another one using interactions between, or creating a repo rank, and finally a twist on that, which looks at projects that also have a protocol, but have developers that have been contributing to Ethereum back in the day, using them to create the trust seed. So that's the data challenge, which we'll hopefully announce later today. Sorry, a lot of stuff. It's been a busy 2 weeks.
Random question. I mean, tell me if you see it the same way. I'm imagining a world where the Gitcoin project and even say the Optimism retrofunding project, these end up becoming an artifact owned by like an OSO project slug, and then in the future, all these funding events will just be also in the event table, right? So we can join it into our event table. Like you have some kind of funding event, you have some kind of amount.
Yep.
Even like we might even need to add a unit for currency, right?
Yep.
Column.
Yep.
And then the event source would be either Gitcoin or Optimism retrofunding or whatever. But then we can start to normalize this funding data in a way that would be amicable to even more analysis across sources.
Yeah, I would love that. I think the one twist here is we'll probably just need their version. Like right now, the namespace that we have for everything is OSS directory. I think we probably need their own namespace to do that mapping without them needing to conform to our schema or our rules.
Well, we're just importing the raw data right now, so it would be up to us to create the DBT models that would basically convert it into an artifact, right?
Yeah, like we can definitely map it our way, or we can I have some utilities for doing that already, just based on GitHub and addresses that we monitor. But they might have they have a concept of a round, and so a project could change its identity depending on the round that it's in.
Sure, but at least in our data model, that would show up as two different artifacts.
Yeah,
project,
exactly.
Right?
It's the same artifact, but under two different projects. Yeah.
Oh, wait. I heard two different artifacts under the same project. You're saying same?
No, so it would be that, like, say this repo, and then in round 1 it might be associated with some project, and then in round 10 it could be another project. Like the identity of the project has changed.
I see. Okay. Well, we'll have to figure out how to do these types of things, but I think
anyway,
normalizing it would be nice.
Yeah, totally.
Cool. I think I don't know about you guys, but I feel like our demo days are becoming like more action packed, which is a good sign. Like the more that we build, and the better of a foundation we have, which we clearly is better now than it was before. Like, with less effort, we should be able to show more things, which I think is pretty cool.
Yeah, 100%. Good to see you, Santiago.
Yeah, see you.
Hello again.
Hey.
Any other questions or discussions? I felt like we were all talking at 2x speed, and we're already like over an hour, so we can close this out. But yeah, super action packed. We'll have to.
100%. All right. See y'all.
Thanks.